Okay, ladies and gentlemen, let's start talking about adding unlike fractions. Previously we added like fractions, now we're going to add unlike fraction. So adding and subtracting unlike fractions. That's the key, unlike. Now, if I have unlike fractions, that means something like 1/3 plus 1/2. Now, 1/3 plus 1/2 isn't that terribly challenging, except the fact that, unlike the previous ones where I said, hey, bottom of the same, therefore that's the bottom, these bottoms are different. That's no good. What we're going to have to do is get these bottoms the same. Now, the easiest way would be to say, well, this is a 3 and that's a 2. If I multiply top and bottom by 2, so I take whatever's here and multiply it, or I take whatever's here and multiply it over here. Now I have 1 times 2 is 2, 2 times 3 is 6, plus 3 times 1 is 3, over 2 times 3 is 6. Now the bottoms are both 6's, and the tops are now 2 times 1, 1 times 3. I can put them together. 2 plus 3 is 5. It's a sixth, so guess what it is? It's still a sixth. Remember, just like our like fraction discussion, 2 oranges plus 3 oranges is going to be 5 oranges. They stay exactly the same. Now, let's do this using some models. Let's assume that this block right here equals a whole 1. And here's a whole nother 1. And right now I have a half. That should look pretty much like a half over here. So if I have half, that part's good. And a third, that's going to be somewhere in this ballpark. That's a third. So I have 1/2, 1/3. Now the problem is they're not like pieces. If I had scissors, I could come up here and I could cut this out and take this little chunk and slide it right up here. Okay, so if we agree, if you let me do that here visually, I have half. I'm going to take that little chunk, I'm going to put it over here. It's going to be just like that, and we're going to get some bigger fraction. The problem is, to put them together, I have to add them in like pieces. Well, if I have 1/2 and 1/3, the closest thing these two go into together is sixth. So I need to break this up not into 2 pieces or into 3 pieces, but into 6 pieces. So here we go. 1, 2, 3, 4, 5, 6 pieces. 1, 2, 3, 4, 5, 6 pieces. Now in this case I have this, this, and this were my half. That's 3 out of 6. Here I have 1, 2, and that's 2 out of 6. So it's going to make sense that I'm going to end up with 1, 2, 3, 4, 5 out of 6. 5, 6. So that's using models, okay? Using models to add them up by getting common denominators. The problem is, what happens if I have, 3/10 and 4/5? Now I have to break that up, and I'd have little pieces with 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't need that bit. That part's gone. And we have the same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. And I have 1, 2, 3. I got ahead of myself. This would only be separated into groups of 5. But to put them together, I would have to say, can I turn 5 into 10? Well, I can turn a 5 into a 10 if I multiply by 2 and 2. So in this case, I'm going to have 3/10 for this one. And now I'm going to end up with 8/10 for this one. 1, 2, 3, 4, 5, 6, 7, 8. And now, when I go to put all that together, I'm actually going to have 8, 9, 10, and I'll even have to put another one on here and make 11/10. Now 11/10, you'll notice I had to add something on because 11/10 goes above 10/10. That means that I have more than one whole strip. I have a whole strip plus another one. So I would end up with 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and one more. Well, you'll notice 1 and one more means I have a whole big strip and one little tenth left over. So we can go from improper fractions to mixed numbers. Because this improper fraction where the numerator is bigger than the denominator can't be left. I have to say that's one whole strip plus one more little tenth. So, adding unlike denominators, models work out okay, but really we need to be able to do common denominators using only numerical values. So if I have 1/7 plus 3/14, let's practice that one. Then let's practice 3/8 plus 1/3. Now, in the top case, I have 1/7 and 3/14. Can't put them together because they're not the same. But can I change a 7 into a 14? The answer is yeah. If I take 7 times 2, that makes 14 on the bottom and 2 on the top. And then that's plus 3/14, a total of something 14th plus something 14th is something 14th. The denominator stays the same. You end up with 5. All right, now we have 5/14. On the bottom, I have 3/8 plus 1/3. Now, unfortunately, I can't add eighths and thirds together. They're not the same type of thing. So here again, I'm going to use my little trick that I'm going to change both of them. And in this case, I'm going to take the 3's, put them over here. I'm going to take the 8's, put them over here. And I have 9 over, well, 3 times 8 is 24, plus 8 over 24. Now, whatever I add up is going to be over 24. 8 plus 9 is 17. 17 over 24. So I have 5/14 and I have 17 over 24. All right. So that's how you add fractions that don't have the same denominators. So same denominators, not same denominators. Finally, let's go ahead and add one other crazy little thing. If I have 1 3/5 plus 2, better make it a big O2, 2 1/2. All right, now I can't add the little numbers, but I could add the big numbers. So 1 plus 2 is 3. The problem is I can't add 3/5 and 1/2. So what I'm going to have to do is get common denominators. Over here I'm going to bring the 2's. Over here I'm going to put the 5's. And I end up with 6 over 10 plus 5 over 10. And so I have 1 6/10 plus 2 5/10. I still get my 3. But now I end up with 11 over 10. Now you say, uh-oh, there's that problem again. 11 over 10 is too big. So I say, how many 10s fit inside 11? One whole number fits inside 11, and then that'll leave 1 left over. So I take that 1, and just like when I'm adding, I carry that 1. Just like if I had 14 plus 7, I would say 4 and 7 is 11, so I put one of them down here and I carry the 1 to make it 2. Same way here. I'm going to carry that 1 and turn them into 4 1/10. 4 1/10. So that's going to be my answer. That's going to be my answer there. All right. So that's adding unlike fractions.